So in terms of telling you about me, I'll give you two parts to that. So there's the journey before wood, and then there's the journey after wood, or since wood. And I guess, so growing up, I grew up in the bottom of New Zealand, and lots of wide open space, ran around on the rivers and the alpine passes around Fiordland and Mount Aspiring, and lived a pretty cruisy life. And originally, I wanted to be a park ranger or an alpine guide when I grew up. So I went off and studied conservation biology and resource management and recreation theory, and got halfway through doing that, and worked out actually no, I was probably more suited to being an engineer. So mid-degree had a big switch and went off and studied a course which was a dangerous combination of civil engineering, mechanical engineering, and forestry science, and then finished my degree and fell into the world of plywood, and then not long after that found myself working on laminated veneer lumber, commissioned a couple of greenfields plants, one in the north of New Zealand and one in WA. So yeah, a couple of them under my belt. Then had a complete change, went back to native hardwood sawmilling in regional Victoria, and was the operations manager for a miller down there, and also a glulam producer. Had a break from operations management for about 5 years, running the Engineered Wood Products Association of Australasia, and started this year decided it was time to get back to the commercial world. So I'm now the general manager of research and development with AKD Softwoods.
Yeah, fantastic. It's such a diverse background of experience about understanding what kind of goes behind the scenes a little bit when it comes to the products that we all design with. So, and I was personally blown away the first time I went to a sawmill and started to actually peek behind the scenes of a supply chain, and blown away by what actually happens. So can you start by telling us a little bit about the process of what goes behind the scenes in turning a log to a product, and what are some of the goals that we're trying to achieve here?
Yeah, sure. So probably the first question is which logs and which products. It starts well before the wood processor. So the logs that AKD would want as a sawmiller aren't going to be the same logs that a particle board manufacturer is going to want. We generally want straight, long particle board guys are probably more interested in just volume, and the form doesn't matter as much. So right back at the forest stage, there's a whole lot of decisions go on around what logs should be made in the bush, and what customers they should be distributed to. So we then get our logs as a sawmiller, and we'll break them down into a green product. For us, it's sawn boards. For LVL and plywood manufacturers, it's veneer. But whatever your process is, there's a green process, green breakdown stage. It'll then typically get put through some sort of drying process, take the moisture out of the wood, and then as a sawmiller, we'll dress it, grade it, sort it into various products. So AKD's primarily a structural timber producer, and produce machine graded pine. So from our process, that's for some of our products, that's the final stage. There's other products that we'll put through some sort of durability enhancement. So we have a Terminator product, termite resistant framing. We've got Endura for above ground outdoor, Ironwood for in-ground landscaping products. So we go through this durability enhancement process. Sometimes products will go through further processing, so they'll be moulded into profiles. So that's the sawmilling perspective. Then the wood composites, the process is similar in primary breakdown, drying, whole lot of grading and sorting of fibre, and then the wood composites guys will think about how do you put that fibre back together in a way which delivers the outcome that customers are going to want, whether that's about strength, whether it's about stiffness, better appearance, doing things with stability, making longer lengths that you can typically get from a log. So it's just working out what is it that customers want, and what are you trying to do with your composite products.
Yeah,
so that's the basic steps.
Yeah, well, there's so much involved in all of that. And I'm sure there's been technology that's been employed over time. Like, what is the latest in the cutting edge of technology? And I guess take your pick out of all the different areas you just mentioned. Whether it be grading all the way through all the other things.
Yeah, it's hard to pick out one that's cutting edge. There's people walk into our particularly our Colac green mill, and the comments that they make is they're looking for Captain Kirk to appear on the bridge of the Enterprise. It's it just completely blows them away, the number of screens that people are looking at, the data that's in front of them, the visualization and rendering of the material that's going through the process. But the technology is right through the whole operation. When you look at our green mills, one of the key things that we're trying to achieve is recovery of fibre. So every percent that you don't recover is fibre lost. So every log that comes into a mill is scanned, so geometric scan, understand the shape, and work out what the cut solution is going to be for that log. So where are the saws going to be positioned? How are each of the slabs, I guess, that are cut off that log, how are they then going to be broken down into boards beyond that initial breakdown? So a whole lot of optimization going on with that, and mathematical processes that are just churning on computers in the background. So that's a technology that people see, and it stands out when you walk into mills. But there's other technology around visual scanning, so looking at knot structures, finding defects in timber, working out different structural grades. There's sonics going into it. So we were using X-ray technology to understand density of wood. We're looking at CT scanning. All these, when I think back to when I was a kid, CT scanners were a new thing, and I can remember going to a hospital with my parents because they were showing it off. And now we're talking about putting them into sawmills to be able to run a CT scan of a log. There is heaps and heaps of technology goes into our processes now. Lots of data, lots of analysis, lots of work to really try and optimise what it is we're doing.
And I guess is the whole push in innovation been to improve the utilisation of the log, and has that improved over time? So we're finding a home for more material in the log.
Yeah, so there's three. When we break a log down, there's three key considerations from a processing perspective. So physical recovery is one of them. So how do you get as much wood fibre as you possibly can out of it? The productivity of the plant's the second one. So you've only got so many hours in a day. How do you get the desirable volume of wood through that mill in the hours that are available? And then the third one is, what's the value that you're generating? So really easy to get good recovery and good productivity producing a whole lot of products that people don't want. But you don't produce any value. We're just constantly trying to manage this optimization of the volume that we recover, the rate that we can recover it at, and the value that's going to provide for customers. So definitely technology helps that, absolutely. The technology is often significant capital investment. So it's got to have a payback to it, and that payback can be through any one of those factors of recovery, productivity, or value. But there's always opportunity for finding new ways of using wood fibre. The way trees grow, your best wood is the wood that they grew yesterday, typically. So it's around the outside. Round logs into rectangles. It's really hard to put a rectangle on the outside of a log, but if you want to, it's got to be smaller. So do we cut smaller sizes and then find ways of putting them together further down the process? There's lots and lots of discussions go on around how do we get more fibre for building, and given that Australia is we're a resource constrained industry in Australia, trying to find ways of making our resource go further is really important.
Yep. Yeah, and what is to say the difference between a softwood and hardwood when it comes through that whole process and all the way through, and how might it be treated differently?
So from a processing point of view, so AKD softwoods, we're a softwoods processor, and one of the big advantages of softwoods is they tend to be a lot easier to dry. In a past life, I was the ops manager for a hardwood sawmill, and drying hardwood and drying softwood is a completely different game. We're drying different pine species. Generally, you can run relatively high temperatures, and when I'm talking high temperatures, I'm talking 120, 140 degrees. And relatively short drying time, so less than a production shift. When you start talking about hardwood drying has typically been air drying, so you're talking months, not hours, sitting outside, just very, very slowly drying, and then finishing them off in a kiln. But even when you're finishing them off, you're talking about even for thin material, at least 24 hours of drying time. So because of the structure of the wood, you're doing very different things to try and control any damage that you might cause in the drying process.
Absolutely. So we've spoken a bit about improving the recovery rate from the log, and then say once we've got different grades and different types of timber and turning it into a product. How can we, say, increase the value of a product, and probably drawing on your experience as the CEO of Engineers Wood Products Australia, which is another one of your previous roles, how can we turn them into engineered wood products, and how do we improve the actual overall performance in doing so? I
think I might step back from that question a little bit, and in my mind, it's how do we improve the value of the forest? One of the, I mentioned earlier, one of the issues that we've got is that we're a resource constrained industry, and we've got people that are wanting to build with timber. There's to be able to satisfy demand at any given time, there's a need for imports. Right now, imports is a real challenge, obviously. So how do we make the resource that we've got go further than what it currently is? And I think there's a combination of things around that. One is looking at what do we need for performance in different parts of a building. We build non-load bearing walls out of 90 mil studs. Do they need to be 90 mil studs? We build bottom plates using structurally rated timber. Does it need the structural rating when it's a bottom plate sitting on a concrete slab? So there's questions that we've got to ask around that, and that's not a designer question on their own. It's not a manufacturer question on their own. It's something that we've got to try and work out. How do we collaborate on? How do we build a supply chain based solution? That's about extending the total forest. I think in terms of the engineered wood products, one of the big things about wood processing is you're trying to take this highly variable natural material and turn it into something that engineers who love consistency and love predictability can use to build a structure which they're confident is going to be safe. They know it's not going to fall down in reasonably foreseeable circumstances. whether it's sawmilling, whether it's engineered wood processing, the aim is to try and give the customer something which is predictable. So lots of technologies go into that. Sawmilling we've talked about. You start getting into veneer-based products. It's about grading veneer and randomisation of defects and reducing the amount of variation, increasing the reliability. Glulam, there's more opportunities for glulam, and I'd mention that you can cut small rectangles from the outside of wood. Good wood fibre, but too small to really be useful in a structure. So how do you laminate them and create a size that's useful using really good wood fibre that's currently otherwise probably getting chipped.
Absolutely. And you mentioned there about improving the value of, say, our forests. Do you think that, improving the value of products and the whole equation, we could actually incentivise land use change, across the country if we're providing, a better yield on growing trees from products? I mean, if it improves, do you think that there might be more land use change for other forms of agriculture towards forestry? Is that something that you think could happen?
Certainly something that gets thought about in sawmilling businesses. So resources is pretty important. If you don't have trees, you don't have a sawmill. I think definitely the challenge for the forest grower is about getting a return on a long-term investment. So there's a lot of upfront cost. They've got to discount that cost over a long period of time. So they're wanting more value from the logs that they're selling at the end of their rotation. The challenge that then raises for the processor is how do we get more value out of the logs that we're processing? So how do we recover more fibre? How do we use more fibre? How do we put that fibre into products that the market's going to be prepared to pay more for?
Yeah, great. And as we're going towards the end, so looking at all these processes happen, how do we maintain quality in products and certainty that, say, the designated engineering properties are actually going to be achieved and whatnot, so designers can have confidence in what they're specifying?
So I guess from I'll share the AKD perspective on that. That's what I'm responsible for these days. So from an AKD perspective, it's really about lots and lots of monitoring. So monitoring is of machinery, calibrations, making sure the set points are right, making sure that processes aren't drifting, making sure that within our own process we've got control and our own predictability in that process. That's backed up then with lots of monitoring and measuring of the materials, the physical materials themselves, so timber going through the process, and that's right through the process. So from log, green product, material going into the kilns and understanding density distributions, understanding kiln drying conditions, taking timber in the dry mills and testing them for stiffness and destructively testing them for strength on a regular basis. So there's lots and lots of activity goes on in sawmills to make sure those things are happening. What we do is we back that up with a third party, and I'd said earlier that I had worked for the Engineered Wood Products Association. We don't use the Engineered Wood Products Association because I was there. We were using them before that. But they're a third party that will come into our business a couple of times a year and go through our records. We'll talk to our operators. Will ask us questions about what we're doing. And they'll also take material independently and destructively test that a couple of times a year to make sure that it's not just us saying we're good guys, it's actually someone else is prepared to attest to it. And I mean, the Engineered Wood Products Association, they're timber specialists. Their background is in or their expertise are entirely in timber. So they ask the hard questions when the hard questions need to be asked, and that we think gives us a level of confidence, and it can give our customers a level of confidence.
Yeah, absolutely, and no doubt super important. So my final question, Dave, before we wrap it up, what excites you about the future of timber, and where are the next innovations coming from that you're seeing in your role, do you think?
What excites me about the future of timber? There's lots of things that excite me about the future of timber. I think there's exciting opportunities around carbon, and we're now talking about a net zero 2050 is maybe on the horizon with a bit of luck. So opportunities around carbon and looking at production forestry opportunities is one of the ways to meet our goals. There's lots of opportunities around construction, so buildings a whole lot faster with off-site prefabrication and quick installation and builds on site. There's new products emerging. There's opportunities around glulam. There's opportunities around prefabricating houses. So there is so much going on in the wood products industry and wood product supply chains at the moment. It's hard not to be excited by them. The other thing that has always excited me about the wood products industry and continues to excite me is that there's some really good people in it, and there's great relationships to be had, and friends that I've worked with for the last 20 years and will continue to work with, and finding ways to solve problems. That's probably that's the thing that probably excites me the most, is that we're not sitting still. We're prepared to try different things, and not all of them work, but the ones that do, hopefully they create some real value for our customers.
That's so good. Well, thanks so much for your time today, Dave. It's been a pleasure to get to chat to you and pick your brain on these things. You are one of the most experienced in Australia on these topics. If people want to find out more about yourself and the work you do at AKD or anything like that, where should we send people?
Look, I'm a pretty quiet character in the public domain normally. Probably the best way, if people want to reach out on some opportunities they think would benefit from some manufacturer collaboration, probably the best way, look me up on LinkedIn, send me a message, ask me the questions, or if you can track down my mobile number, by all means give me a call. If when we get back to having seminars and conferences around the place, if you see a tall guy wandering around with dreadlocks, come over and have a chat, because it's probably me.
We've actually got similar hair, Dave, when I got this out, so hopefully they don't get us mixed up there. But that was awesome. Thank you so much.